Hello, my name is Joseph Waddell, and I'm going to help you learn a new math concept. Today, we'll be covering horizontal and vertical asymptotes. What are those, you may be asking yourself? I haven't seen stuff like this in years. Well, hopefully, I'm going to be able to explain it to you so that you can better understand it. So, I have four problems here in a really poorly drawn graph to hopefully help you better understand. So, just what are these asymptotes that are just such an odd word to hear? These dotted lines are commonly denoted as asymptotes, and usually they help to explain how a graph isn't always continuous. Like normally, you see a lot of graphs that are just straight lines, they don't have any breaks in them. But here, this is an odd graph, and this is actually a common parent function. F of x equals 1 over x. This is a rational function. This is most likely the kind of function you'll see that has an asymptote where it's not continuous. It never touches the x or the y axis because of this. The x in the denominator of this function will not it cannot equal 0 because you can't divide anything by 0. That's just not mathematically possible. So anytime you have an asymptote, you don't just write, oh, there's an asymptote at 0. Which 0 would it be? X equals 0, y equals 0? Who knows? That's why it's really important that if you have a vertical asymptote, you have to write it as x equals 0. And if you have a horizontal asymptote, y equals y equals a number, and same for a vertical asymptote, x equals whatever number it may be. So let's get to the examples. Here in number 1, how do you get the vertical asymptote, which is usually what I tend to do first because I think that's easiest to get out of the way. You set the bottom portion of this rational function equal to 0, not the top. Ignore the top for now. So here you'd only have 2x plus 5 equals the 0. And then that's just simple linear algebra. Just subtract the 5, divide the 2, and then you have x is equal to negative 5 halves. So you have a vertical asymptote at x equals to negative 5 halves. So that would just look like a dotted line, only it would be like somewhere over here instead of straight down the middle. That's really a general example of how to get most vertical asymptotes like that are pretty easy to get. Now the horizontal asymptotes have three different ways that you can get them. You have ones where degrees are the same. The degree on the top is bigger than the one on the bottom, and the degree on the bottom is bigger than the one on the top. I'll explain what a degree is. Here, you want to find whichever x, if there's an exponent in it, if they're the same, like here it's 3x, here it's 2x, here it's 3x to the 7th, 2x to the 4th, that's way different. But here, they're the same. It's only 3x and 2x. Just ignore the constants. They're not important. You want to look for the term with the highest degree, and then that will be what you use to find what you look for horizontal asymptotes. So here, you just use the leading coefficients, or the number in front of these x terms with the highest degree. And then you just take the top one, divide it by the bottom, and there's your horizontal asymptote. In this case, it would just be y equals 3 halves. So that would be a horizontal dotted line somewhere like around here or something. And that's where these curves, they can never touch that line. Well, that line in that example's case. So that's how you find those asymptotes in this example. Moving on to the next one. This one is pretty simple to find a vertical asymptote. Here, because it's x squared plus 27, anytime you see an x squared or any even x to an even exponent, it will be a pretty much almost always it'll be any number you put in here will never make this 0. So in this case, there is no vertical asymptote. However, there is a horizontal asymptote because in this case, to find it, the degree on the bottom is bigger than the top. Anytime the degree on the bottom is bigger than the top, you have a horizontal asymptote at y equals 0. So, similar to this example, because the degree on the bottom is bigger than the degree on the top, this is also y equals 0. So there's just a line going straight through the x-axis. So that one's pretty easy. This next one is also pretty easy. To find the vertical asymptote, all you have to do is set the bottom equal to 0. Here, all you have to do is just x is 0, 0 to the 4th, 0 times 2, 0, so 0. X equals 0 is a vertical asymptote, and for this rule, with the horizontal asymptote, because the degree on the top is bigger than the degree on the bottom, here there are no horizontal asymptotes, so no horizontal asymptote and vertical asymptote here is x equals 0, so that's just similar to this vertical line straight down the y-axis, really easy. And for this final example, I put x squared here at the end, but this proves that whenever, well, let's do vertical asymptote first, getting ahead of myself. Here, just set the bottom equal to 0. This is similar to the last example. Here, it's just you have a vertical asymptote at x equals 0, so that's another really easy one to think up and do. And to get the horizontal asymptote, here, just look at the degrees. The 12 is here to confuse you. Never worry about the constants. Only look at the x terms in their highest degrees. Here, they're both 2, similar to this example. So here, it would be the leading coefficient. Anytime you just see a plain x, just imagine there's a 1 right in front of it. Just imagine that imaginary 1 right there. So here, you'd have 1 over 3. That's just 1/3. So you have a horizontal asymptote at y equals 1/3. So here, there would be a vertical asymptote straight down the middle, and horizontal asymptote would be somewhere like right here, just in line straight across. Hopefully this can help you better understand the mathematical concepts of asymptotes. Thank you very much. Have a good day.